Hello my dear PU2 champions. Now that your rapid revision is over for determinant and your one marker is also done, it's time to solve some questions. They're not difficult, but they are quite calculative in nature, basically from the subjective category of 2 marker, 3 marker, 4 marker, 5 marker of determinant chapter. Right? So yeah, there are some calculations involved here, but that's the only challenge. There's no other challenge apart from that. Okay, so we'll see all those questions. Yes, are you ready for it? If you are, let me know in the comment section you're ready to solve these questions right away. Okay, so please make sure that you have the pen and paper with you right now, because I might ask you to do the calculations with me. Okay, I might need help in that, right? So you help me by putting your answers in comment section. I understand it is a recorded video, but still when I see your comments, it means that you are participating in the lecture, you are learning in the lecture. Okay, that gives me energy to come here and teach you with higher energy level. Okay, let's start. So as I said, question 1 to question 5, I have taken the category of 2 to 3 marker. Means these questions can be asked in either 2 marker or 3 marker. So basically they are both the same categories, and 6 to 8 will be a 4 marker category, and question 9 I have taken one question as 5 marker, because other questions are very similar. You can actually if you understand how to apply inverse, that is all that you need to solve that 5 marker category questions. Okay, from the chapter determinant, of course. Let's start the question number 1. Okay, question number 1 is here, sir. 2 3 marker, please check. Find the equation of the line joining the points. Very good question. They're saying that there's 2 points given over here. The point is like this: 3 1 and 9 3. Okay, they're asking you to find the equation joining the points 3 1 9 3. Now what will happen? A lot of students, they have learned CG, right? They have learned CG in their grade 10. They'll start taking find the slope, sir, and then using that slope point form we can use, sir, or maybe you have 2 point form, sir, we can use 2 point form formula, get the result. Okay, but you actually not applied over here. You can do that if it is an objective question and you have to get the answer, but in here they want steps as well, so you have to use the approach of determinant, not CG, not coordinate geometry. Okay, so basically assume a point here x comma y, and the determinant way is, if this is the point on the line, it means all 3 points has to be collinear. Superb. Check here. So we have 3 1 9 3 xy 1 1 1, and this will be equal to what? 0, because they are collinear, right? It means determinant of the coordinates matrix will be always 0. Let's find. I find across the point the first row itself. So 3 will be 3 minus y, excuse me, I get minus 1 over here. Second element, this is gone, 9 minus x, right? 9 minus x. Okay, and the last one is plus 1 over here. I get 9y minus 3x. I get 9y minus 3x. This whole thing is equal to 0. Okay, perfect. Now next part is the, of course, simplification, and we get here 9 minus 3y minus 9 plus x, okay, and plus 9y minus 3x equals to 0. Minus 9 plus 9 is cancelled. Simplify now. 9y minus 3y is 6y. Minus 3x plus x is what? Is minus 2x. Bring this on that side, we get 6y equals to 2x. It means x equals to 3y. This is my equation. If you want to write in the form of on the only one side, we get x minus 3y equal to 0. So either you write the first or the second way of the answer. Both of them are correct. Please check. Okay, so your answer is either x equals to 3y or x minus 3y equals to 0 for the first question. Can be asked even for 3 marker as well. Okay, this can be asked for 3 marker as well. Very good question. Superb. This is my point A, point B, and point C. What is it? ABC is collinear. ABC is collinear. Okay, all right, this is good. Please check. Let's move on then to question number 2. Question number 2. What is it? It says, if the area of triangle with vertices minus 2 0 0 4 0 k is 4 square units. Find the value of k using determinants. Okay, in this case they have given the area, they have given the coordinate, but they are asking the missing value. Remember, I taught you this thing even in the rapid revision. I told you this kind of question can come, very common. Since they have given everything, so right here 1 by 2 times of the determinant minus 2 0 0 4 0 k 1 1 1 is given equal to 4, right? Is given equal to 4. Its area means it has to be both plus minus, because whether the answer was coming as, let's say, whether the answer was coming as minus or plus 4, the result will always be taken as plus 4, right? Now, because area is always considered as a positive entity. That's why when we are taking the area 4, we have to assume that, I don't know whether it may be plus 4 or minus 4. I hope you're getting it right. Let's say I solve a determinant and I get the answer as minus 4. For a case where I solve this thing and I get the answer as minus 4, what is the area? Area is 4 only. I cannot take minus 4, right? Area can never be negative. So that's why when they have given the area as plus 4 and we are going to solve the equation format, I have to bring back the plus minus sign again. Okay, chali. Take this 2 on that side and solve across first column, because we have 0 0 over here. Minus 2 4 minus k equals to plus minus 8. I'm taking this 2 on this side. I get here minus 2 times 4, which is minus 8. Excuse me, very silly of me to multiply these two like this. Yeah, this is minus 8 plus 2k is plus minus 8. I have two options now. Let's break both of them one by one. Minus 8, excuse me, minus 8 plus 2k equals to minus 8, and minus 8 plus 2k equals to plus 8. So minus 8 gone, we get k value as 0. Over here you check, I can bring this on this side. I get 2k is 16, k is 8. So your two values of k is either plus 8 or 0. Plus 8 or 0. Simple question, can be asked in 3 mark as well, but yeah, can be asked in 2 marks also, but usually they ask this question in 3 mark paper. Okay, so 3 mark problem, I mean, in the paper. Clear? Question number 2 is also clear. They had given the vertex, they had given the area, but what happens as a student, we forget to write the plus minus sign. Let's not do that, because the point is very simple. Let's say the area is not given, you're finding any determinant, any area using the determinant form, and the answer comes out as negative. Will the area be negative? Of course not. Okay, so you have to take that negative value to be assumed as positive, because the quantity is area here. So that is why when we're taking the area quantity and we're equating to the equation form, I have to assume both plus minus sign. No, okay, even though this was minus 4, answer will be plus 4. If this is plus 4, answer is plus 4. That's why I'm taking both plus minus sign over there. Okay, question number 2 is clear. Let's move on to question number 3 now. Find the inverse of, third is find the inverse of the matrix. This is a very simple question, 2 marker. Can be asked in actually MCQ also, right? Yeah. This is A. 2 minus 2, 4, 3. What's the first step to find inverse? First step is to find the non-singular property of matrix. 3 into 2 is 6 plus 2 into 4 will become 8, so 14, right? This is minus sign, will become minus of minus, so plus, right? Plus 8, 14. Okay, now adjoint, we all know, will inverse these two. 3 will go here, 2 will come here, it will become plus 2, it will become minus 4. That's my adjoint. So inverse is what? 1 by 14 times of adjoint. 3 2 minus 4 2. That's your answer. Check. This is a 2 marker or 1 marker question. Okay, not 3 marker. This will not come as 3 mark question. Question number 4 now. Examine the consistency of the system of equations. Okay, this is a 2 variable question, right? Very simple. We have the form a1 by a2, excuse me, yeah, a1 by a2, b1 by b2, C1 by C2. Let's find these values. Let's find these ratios. 1 by 2. Here 3 by 6, which is nothing but 1 by 2. And lastly minus 5 by minus 8. How much is that? 5 by 8. What is the conclusion from here? What is the conclusion? Conclusion is that A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. 1 by 2, 1 by 2, 5 by 8. So first two ratios are equal. The last one is not. What it gets? No solution. Okay, basically parallel lines. Both the equations you see over here will represent a pair of parallel lines. A pair of parallel lines. I hope this makes sense to you. Okay? Yeah. Already discussed this in the rapid revision, right guys? Yeah. So next move on to question number 5 now. If A is a square matrix of order 3, then prove that determinant. Basically they're asking us the proof of the property. Remember we have learned a property, right? Same property they're asking us to prove. Order is given as 3. Okay, very simple. Right here A adjoint A. How much is this, dear? This is determinant of A times identity matrix, right? A multiplied with adjoint A is determinant of A times I. This is a property. We have known that, we have learned that, we have seen it. Okay, now take determinant on both sides. Check. This determinant of A is a constant or not? It can be 5, it can be root 5, it can be anything but a constant, right? It is a scalar value. So basically this is coming out as a constant k times of I. So this will become what? The constant will come out with the power as order. Yes or no? If you take determinant on this side, what happens here? This constant will come out of the determinant with the power as order. Order is in this case 3. We'll write the 3 next. Determinant A power 3. And determinant of I is what? Is 1. Okay. And on this side you check. We have two matrices over here. This is a matrix and this also is a matrix. Right here. A determinant of adjoint A. Here you see A determinant of adjoint A. Now I can cancel this too with this one. You get a square over here. I'm getting here adjoint of A is this. Please check. Determinant of adjoint of A is determinant of A square. Because this 3 was there, no, I cancel this with the extra determinant of A on this side by moving it on the RHS side. Proved. Please check. Same thing. It's a proof of the property, okay? Can be asked in 2 marker. 3 marker I don't think so, but yeah, maybe sometimes, but usually 2 marker. Okay, let's move on to question number 6 now. Question number 6 is part of your 4 mark category questions. Okay, now let's have a look. They've asked us to find, okay, they have to ask you first to verify A square minus 5A plus 7I and then find the inverse of A. Okay, so one way to find inverse of A is, we know that, right? Find that joint here with the trick that we have learned. Divide by the determinant. Easy for this question, 2 cross 2. Otherwise what you can do is simply, keep this on this side and rest 2 move on this side and multiply with inverse, you'll get the answer. Okay, I'll show you both the method, don't worry. So let's first, but before all of that you have to prove this thing first. Before all of that you have to prove this statement first. And how do you prove it? You have to find A square, 5A and 7I. Let's find A square first. It is 3, 1, minus 1, 2, 3, 1, minus 1, 2. What I get? 9 and minus 1, which is 8. Okay, 3 into 3 is 9, 1 into minus 1 is minus 1, so 8. I get 3 and plus 2, which is 5. Minus 3, minus 2, right? Minus 3 and minus 2. So minus 5, correct? Minus 3 and minus 2, correct? We get minus 1 plus 4, so 3. Minus 1 plus 4 is 3. That's my A square. Let's find 5A now. What I get at 5A? 5A will become 15, 5 minus 5 and 10. Yeah, okay, 5 into A, this is their 5A. 7I you already know, so let's use that together now. So we have I can use it over here, A square minus 5A plus 7I. Please check, we get this as 8 5, okay, minus, excuse me, this is 15, yeah, that's 15, 5 minus 5 and 10 plus 7 0 0 7. Add all of this, what do you get? 8 minus 15 is minus 7 plus 7 is 0. 5 minus 5 is 0, so 0. Minus 5 plus 5 is 0, so 0. 3 minus 10 is minus 7 plus 7 from here, again 0. This is coming out as 0 matrix with the order 2. We are asking that only. 0 matrix. Okay, answer is 0 matrix. Yeah, so proved. This here is proved, sir. Next step is what? What is next step? To find the inverse. Now to find the inverse, one method is what? Simply write the statement, okay, as 7I equals to 5A positive minus A square. Multiply inverse on both sides. A inverse, you get A inverse 5I will become minus A. Okay, and from here basically I'm multiplying, right, with A inverse on every term, right, over here. So it will become 7 into A inverse into I, which is 7 A inverse. A inverse into A is I, so that is 5I, and one of the A will be again becoming I, so I into A will be A itself. Okay, if you're not sure, don't worry, just do your own calculation and check. Okay, so A inverse will become equal to what? 1 by 7 times of 5I minus A. Okay, that's your answer. 5I is, you know how to find 5I, you know A value already, so you can use that to get the result. That's your A inverse value. But this is the matrix approach. What about determinant approach? You can find it. What is A given as? 1 second. A is given as, just give me 1 second, 3 1 minus 1 2. 3 1 minus 1 2 is the value of A. I'm looking for a joint first. Will become 2 3 minus 1 1, right, and that's my joint A actually. Determinant is how much? 6 plus 1, which is 7. Answer will be what? 1 by 7. 2 minus 1 1 3. Now in this case this is easy to find, that's why we got it faster. This is method number 2 to find inverse, and method 1 was here. Please check. Method 1, you can find inverse like this or like this, your choice. Okay, both of them are correct. You'll get full marks for both of them. But in this question actually the desirable method is this, but this if you do, not wrong. Next up we have question number 7. Okay, so I hope this is clear, right? This is clear. No, everything is clear over here. Please check one last time, have a look. Yeah, all right, let's proceed then. Okay, so we have a matrix given to us. We are looking to verify A adjoint A is equal to okay, we are to verify the property and find A inverse as well. Okay, we'll do it. First thing basically is to find the adjoint over here, nothing else. Okay, we can find determinant also, right? Find across. Okay, first row only. I get 1 times of 16 minus 9, so that is 7. 4 for the 16, 3 into 3 is 9, so that's 7. Minus 3 times of what? 4 minus 3, that is 1. And the 3 times of 3 minus 4 plus 3 times of 3 minus 4. Okay, so I get here 7 minus 3 again. Answer is 1. Determinant of A is coming as 1. This is coming out as 1. Okay, if you're not sure, do the calculation from your own side. Okay, This is okay. Let's move on to the adjoint part. So RHS is clear that it is going to be anti-matrix. Let's work on LHS. Adjoint of A. Adjoint of A. So what we do in adjoint, write the matrix again. 1 3 3 1 4, and repeat the first two rows over here as 1 3 3. The first row is done. Second row 1 4 3, and the first two columns. Okay, we get 1 1 1 1 1 3 4 3 3 4. Okay, that's my 5 cross 5 matrix after repeating the first two row and the first two columns. Okay, next is eliminate first row, first column. From here, this is eliminated, right? So start like this. You'll get the adjoint. So your adjoint of A. Have a look. 16 minus 9, that's 7. We have 9 minus 12, that's minus 3. Last is 9 minus 12 again, that's again minus 3. That's a first row. Do in the vertical format, get the answer in the first row. Okay, same way for the second column. For that I'm going to erase this first. Okay, just to avoid any confusion or lack of clarity. Next up, we'll start from here for the second row. 3 into 1 is 3, and 1 into 4 is 4. That is 3 minus 4, which is minus 1. And next up we have 4 minus 3, which is 1. 4 into 1 is 4, 3 into 1 is 3, so 4 minus 3 is 1, and 3 into 1 into 3 into 1, that's 0. 3 minus 3 is 0. Okay, we can start from here as well. 3 minus 4 is minus 1, right? 3 minus 4 is minus 1, 3 minus 3 is 0, and the last one, 4 minus 3 is 1. That's my adjoint of A. That's my adjoint of A. To find A adjoint A, right? Let's close this over here. A adjoint A. Check this out. I'll write A first. 1 3 3, 1 4 3, and 1 3 4 with 7 minus 3 minus 3 minus 1 0 minus 1 0 1. Okay, come on, let's start. So let's multiply this now. Looks difficult, but it is not actually. I'll show you from row to column. 7 into 1 is 7, starting from here, right, and going like this. Yeah, 1 into 7 is 7, 3 into minus 3 is minus 3, and 3 into minus 1 is again minus 3. 7 minus 3 minus 3. 7 minus 3 minus 3 is what? 1. Right? First row, second column now. 1 into minus 3 is minus 3. 3 into 1 is 3. Minus 3 plus 3 is 0 so far, and 3 into 0 is 0. So 0. Again first row, last column. 1 into minus 3 is minus 3. 3 into 0, 0. 3 into 1 is 3. So minus 3, 0, and 3. 0 again. Okay, now we'll move on to the second row. 1 into 7, 7 minus 4, 4 into minus 1 is minus 4, and 3 into minus 3, 3 into minus 1, right? Minus 3. So minus 4 minus 3 is minus 7. You have plus 7 from the first term. You get here 0. If you solve it, you'll get 0, 1, 0, 0, 0, 1. Check this out. What is this? Isn't the same as the RHS? Is it proved? Please check. Is it proved or not? Okay, I start from A adjoint A. I'm getting this equals to I. So it is proved, right? Any problem? No? Yeah. Okay, so next what they're asking? Finding A inverse. Formula is what? Adjoint of A by determinant of A. Determinant is how much? 1. We just found, no? It was coming as 1. It becomes simply adjoint of A. So your inverse is nothing but adjoint of A. Your inverse here is nothing but simply this adjoint of A. 7 minus 3 minus 3. 7 minus 3 minus 3. we had minus 1 1 0 and minus 1 0 1. That's my inverse. Please check, guys. Okay, if I made any mistake in calculation, you have to let me know in the comment section. I have tried not to, but if I have, let me know. Okay, clear? All right, this is clear, quite clear. Okay, done. Let's move on to next question. Question number 8 now. Question number 8. Okay, so it says A equals to 3725, B equals to 6879. Verify AB inverse is B inverse A inverse. Basically the property, right? You all know how to find A inverse B inverse. That is a very easy task. A inverse you can find, B inverse you can find. I'll give you this as homework. Okay, A inverse B inverse you can find, right? 15 minus 14, right? Yeah. Okay, so question number 8. If A equals to 3725, B equals to 6879, okay, we have to verify the property. This is the property, right? This is a property. Okay, next what? You all know how to find A inverse B inverse in 2 cross 2. It's very simple, right? 15 minus 14, that is 1. That is the non-singular form. Determinant is 1. 9 6 are 54 and 8 7s are 56. This is minus 2. Okay, so please use this and get the A inverse B inverse value. I'll help you in this question, but this will be a homework, don't worry, and try it though, not difficult. I'll solve the difficult part, you can do the easier one, but please try from your side as well. AB here, multiply AB, multiply this. So what I get if I multiply 3 into 6, 7 into 7, that's 18 plus 49, 67, right? 18 plus 49, yeah, that's 67 only. Yeah, and 3 into 8, that's 24, and 63, so 87. Yeah, 87, and this one 2 6 12 and 35, so 47, 2 8 16 and 45, so 61. Yeah, AB we got. We want to find AB inverse, so we have to find first determinant of AB. It will become 67 into 61 minus 87 into 47, right? How much is this? Check this out, guys. 6 7 6 1 7 and 6, 2 carries 4, 40. I get 4087. That's 4087. If I remember, this will be coming as 4089 actually. This will become minus 2. The determinant of the matrix AB is minus 2. Okay, finding inverse of AB is quite simple from here. Then how do you find it? Remember, switch this element. 61 comes here, 67 goes here, and the sign change over here, minus 87 and minus 47, and this whole thing divided by what? Divided by minus 2. Okay, so this is your AB inverse. So your AB inverse is coming out as minus 61 by 2, 87 by 2, 47 by 2, and minus 67 by 2. That's my AB inverse. Okay, now you have to find B inverse A inverse. You can do that, right? You can do that, finding B inverse A inverse, same trick to find that joint, and this, and then take the product. You will get the same answer. Okay, try this out. Find this side, find the RHS, solve, and let me know. This is the homework. Comment right now if you have solved it, that verified. If not, solve, and then let me know whether you got the result verified or not. So this is question number 8. Please check. Okay, I'm moving to question number 9 now. Question number 9 is a 5-marker question. Okay, let's have a look. Solve a system of equations given in the 3-variable form x, y, z. How do you do it? Of course, make the matrix of coefficients. We'll make it 1, minus 1 and 2. We have 3, 4 and minus 5. Over we have 2, minus 1 and 3. That's the coefficient matrix. Next we have the variable matrix as x, y and z. Constant matrix is 7 minus 5 and 12. 7 minus 5 and 12 is the constant matrix. So actually we name it like this: matrix A, matrix X and B. I want to find the value of X, right? So I'll take X equals to inverse of A times B. If I multiply inverse on both sides, this will become inverse times A. So basically that is gone, and X equals to A inverse of B. Now how do you find inverse? For that, to finding inverse, I need adjoint of A divided by determinant of A. So basically I have to find determinant of A first. Let's do that. Determinant of A for this part. I can find across the first itself. I have 1. I'm finding across the first row. 12 plus 5, I guess, so 17. Correct now? 4 is 12 and minus 5 into, okay, this is minus, right? Sorry. Excuse me. 12 minus 5. Right? It will become plus 5, yeah, minus 5. That's 7, right? That's 7. Yeah, and this is minus of minus 1, so becomes plus 1, this term. Minus of minus 1, right? Second position is negative position, so it will become plus 1. And we will remove this, we get 9 and plus 10 this time. 3 3 is 9 and plus 10. 19, okay? And the last we have with 2, we get minus, so we have plus 2. And we get here minus 3 plus 8, which is 5. Minus 3 minus 8, sorry. Excuse me. Minus 3 minus 8 actually. Minus 11. Minus 3, 4 into 2 is minus 8. So minus 11. Have a look. I'm getting here 7 plus 19 minus 22. Okay. That's 26 over here. That's 4. So determinant of A is coming out as 4. Have a look. Determinant of A is coming out as 4. Clear? Yes? Okay. So 9th is over. So not over. Just the determinant part is over. We have to find the adjoint first. For that I've already, I've taught you how to find it, right? Write the first 3, like 5, write the first 3 cross 3 matrix, then repeat the first 2 rows, first 2 the columns, right? And then find that this method I taught you over here. This method you use to find the adjoint. It will be faster. So for that I've used and got the answer like this. Okay, that's my adjoint. Once I know that, I can find the inverse. So my inverse will be what? If I know the adjoint, my inverse will be adjoint by that. So 1 by 4 times of the same value. 7, 1 minus 3, minus 19, minus 1, 11, minus 11, minus 1 and 7. Now how do you find X? Is given as A inverse times B. So right here, what is A inverse? Same thing. 1 by 4, 7, 1, minus 3, minus 19, minus 1, 11, and we have minus 11, minus 1 and 7. This with the matrix B, which is 7 minus 5 and 12. Let's cross check multiplication. Okay, 7 into 7 is 49. 49 minus 5 and 12 3s are, so which is going to be minus 36. Okay, that's my first row, sorry, first element, not first row, first element. Minus 9 into 7. Okay, it's going to be minus 133, right? And plus 5, correct? And 12 into 11 is 132, right? Calculation you can do on your own side. If you're not clearly able to understand this, make a pause and do it on your own and get the result. Okay, 11, but don't use the calculator. Do not use the calculator. Do not use calculators. Minus 77. Okay, plus 5 and 84. Correct. 12 7 is 84 is right, and minus plus 5, and this is minus 77. Simplifying this, I get what? 49 minus 41, right? 36 and 5 is 41. That's going to be 8. Here we have minus 1 plus 4 plus 5 actually. This and this is minus 1 plus 5 is 4. This is going to be plus 7 plus 5 is 12, right? I'm getting the answer as 2, 1 and 3. 4 to the 8, 4 to 1 is 4 and 4 to the 12. It means my x, y, z values, which is nothing but the matrix x, is given by 2, 1, 3. X is 2, y is 1 and z is 3. Please check 2, 1, 3 from here. X is 2, y is 1 and z is 3. Clear? So this is the end of your session on subjective questions for the chapter Determinants. So it completes everything that is required to be done for the PU2 midterm revision of the chapter of determinant. If I have missed something, if you want me to do something extra in this chapter, you got to tell me in the comment section. I'll come with the session and help you out with that. Okay, so right now this is it in the session in the chapter. I'll see you again very soon. Till then, take care. Bye bye.